Germany was caught off guard when proximity fuses destroyed entire formations at the Battle of the Bulge. But the story begins 2 years earlier in a secret American laboratory. December 16, 1944, the Ardennes Forest, Belgium. German artillery thunders across snow-covered ridges as Hitler launches his final desperate gamble to split the Allied lines. Luftwaffe formations roar overhead, pilots believing they face the same clumsy flak they've outmaneuvered for years. They're about to discover they're wrong, catastrophically wrong. American gunners crouch behind weapons loaded with shells containing a revolutionary secret, tiny radar sets that can think, calculate, and kill with mathematical precision. These proximity fuses will turn the sky itself into a killing field, obliterating entire German formations in minutes. But how did American factories produce 22 million of these electronic marvels while Germany couldn't even fuel its planes? What happens when democratic abundance meets totalitarian desperation in Europe's frozen hell? Before we get into the story, comment below where in the world you are watching from today. Snow crystals drifted through the pine branches like ash from distant fires. Private First Class Jimmy Sullivan pressed his cheek against the frozen metal of the M1 Bofors anti-aircraft gun, watching German artillery flashes illuminate the ridgeline 3 miles north of Bastogne. The 40mm Swedish-designed weapon had served American forces well across the Pacific and Mediterranean, but tonight it carried something new, shells that would rewrite the rules of aerial warfare. "Fritz is coming hard," whispered Corporal Mike Torres, adjusting the gun's elevation mechanism. The weapon's 4-man crew had held this position for 18 hours, surviving the initial artillery barrage that announced Hitler's Ardennes offensive. 200,000 German troops and 1,200 tanks were massing across a 60-mile front, hoping to split Allied lines and recapture the port of Antwerp. The 101st Airborne Division, spread thin across the frozen Belgian countryside, faced overwhelming odds. General Anthony McAuliffe's men were outnumbered 3-1, with dwindling ammunition and no prospect of immediate reinforcement. German commanders believed their surprise offensive would succeed where previous attempts had failed, but the Americans possessed an advantage invisible to German intelligence. Inside each 40mm shell lay a miniaturized radar set, smaller than a light bulb, capable of detecting aircraft at 70 feet and detonating with split-second precision. The proximity fuse represented 2 years of collaboration between British theoretical physicists and American industrial engineers, a marriage of scientific innovation and mass production that would transform modern warfare. Sullivan heard the distant rumble of aircraft engines echoing across the valley. "Contact bearing 040, he reported, training his binoculars on the horizon. German Focke-Wulf 190s approached in tight formation, their pilots confident that American flak would prove as ineffective as always. They had outrun Allied gunfire for 3 years. Tonight would be different. Dawn broke gray and bitter over Luftwaffe Airfield A1 near Cologne. Oberleutnant Wilhelm Bayer climbed into the cockpit of his Focke-Wulf 190 F8, the most advanced fighter bomber in the German arsenal. Frost covered the aircraft's wings like funeral shrouds, and fuel vapors rose from partially filled tanks, a reminder of the Reich's desperate shortage of aviation gasoline. The FW-190 represented German engineering excellence. But by December 1944, such technological superiority meant little. Pilot training had been reduced to 50 flight hours due to massive casualties and fuel rationing. American pilots received over 200 hours of training in 1942 when resources were abundant. Now German aviators flew on courage and desperation alone. Herr Oberleutnant, called Feldwebel, Hans Müller, the squadron's senior mechanic, fuel load is 60% maximum. Ammunition reduced to preserve weight. Muller's weathered face reflected the reality facing all German units, chronic shortages that rendered tactical doctrine obsolete. Bayer nodded grimly. His squadron had lost 16 aircraft in the past month, with only 4 replacement pilots arriving from training schools. The mathematics of attrition favored the Allies, whose industrial capacity dwarfed German production by ratios that seemed impossible. American factories produced more aircraft in a single month than Germany managed in 3. The mission briefing had been stark. Oberst Friedrich Koller explained that the Ardennes offensive represented Germany's final chance to force a negotiated peace. If the Wehrmacht could split Allied lines and recapture Antwerp, Churchill and Roosevelt might consider terms. Failure meant unconditional surrender within 6 months. "Today we support the ground offensive," Bayer announced to his remaining pilots. Intelligence reports American positions are weakly defended. Their flak has proven ineffective throughout this war. The assembled airmen nodded, remembering successful strikes against Allied convoys and supply depots. American anti-aircraft fire had always been predictable, time-fused shells that exploded at predetermined altitudes, creating scattered bursts that experienced pilots could avoid. 8 FW-190s taxied through morning mist, engines coughing in the cold air. Each aircraft carried 2 250-kilogram bombs intended for American ammunition dumps near Bastogne. The pilots had survived years of combat through skill and intuition, learning to read the sky like a hunter, tracking prey. As the formation climbed into overcast skies, Bayer felt the familiar mixture of confidence and dread that defined Luftwaffe operations in 1944. His aircraft possessed technological advantages over most Allied fighters, but fuel limitations meant each mission could be his last. German synthetic fuel production had collapsed under Allied bombing, reducing the Luftwaffe to a shadow of its former strength. Radio chatter remained minimal to avoid Allied interception. The formation banked southwest toward Belgium, unaware that American gunners below possessed a weapon system that would render their experience and courage irrelevant. The age of proximity-fused ammunition was about to dawn over the Ardennes, Aberdeen Proving Ground, Maryland. November 1942. Dr. Merle Tuve watched a test shell trace a perfect arc against the gray Chesapeake sky. The 5-inch projectile carried the most sophisticated electronic device ever, fitted into artillery ammunition, a miniaturized radar transmitter and receiver that could survive the 20,000 G. Acceleration of being fired from a naval gun. "Detonation!" called the test observer. The shell burst in a brilliant flash 100 feet above the target drone, sending shrapnel through the aircraft's aluminum frame. The drone tumbled into the bay in flaming pieces. Perfect airburst pattern. Tuve, section chief of the National Defense Research Committee, had spent 2 years solving what seemed an impossible engineering challenge. British scientists had provided the theoretical framework for a radio proximity fuse, but practical application required American industrial innovation on an unprecedented scale. The device had to function reliably after experiencing forces that would destroy conventional electronics. The breakthrough came through miniaturization techniques borrowed from the emerging electronics industry. Vacuum tubes smaller than thimbles were ruggedized to withstand artillery forces while maintaining radio frequency stability. Each fuse contained over 30 precision components, packed into a space no larger than a coffee cup. "Every gunner is now a sharpshooter," whispered Colonel William Blanchard, the Army Ordnance representative. Traditional time-fused shells required gunners to estimate target altitude and set mechanical timers accordingly. Even experienced crews achieved hit probabilities below 5% against maneuvering aircraft. The proximity fuse promised to multiply effectiveness by factors of 10 or more. Security surrounding the project rivaled the Manhattan Project. Workers in 200 factories across America manufactured components without understanding their ultimate purpose. Assembly operations were compartmentalized so that no single facility could compromise the entire program. Armed guards supervised production lines where women constituted 40% of the workforce. By 1944, monthly production exceeded 1 million fuses. The industrial mobilization represented American democracy at its most effective. Private companies, government laboratories, and academic institutions collaborating to produce technological supremacy. German industry, constrained by Nazi bureaucracy and resource shortages, could not match such coordination. Testing continued through 1943 with increasingly sophisticated targets. Naval trials in the Pacific demonstrated devastating effectiveness against Japanese aircraft, but the Army insisted on additional modifications for ground-based anti-aircraft weapons. The fuse had to function equally well in Arctic conditions and tropical heat, maintaining radio sensitivity across temperature ranges that spanned 200 degrees Fahrenheit. Dr. Tuve studied production schedules that called for 22 million fuses by war's end. Each unit cost approximately $20, expensive by wartime standards, but insignificant compared to the aircraft they would destroy. A single proximity fused shell could eliminate a bomber worth $50,000 and trained aircrew that Germany could not replace. The first operational deployment approached. Field commanders in Europe had been briefed on the weapon's capabilities, but instructed to maintain absolute secrecy. German intelligence remained unaware that American gunners would soon possess what amounted to an invisible shield over Allied positions. December 23, 1944. 8:06:30 hours. The morning air above Bastogne crackled with anticipation as 8 Focke-Wulf 190s approached from the northeast. Private Sullivan tracked the formation through his binoculars, watching the aircraft descend toward what their pilots believed would be another routine ground attack mission. Range 4,000 yards and closing, reported Corporal Torres, manning the Bofors gun's optical rangefinder. The Swedish-designed weapon had been modified with American fire control systems, creating a hybrid that combined European engineering with American mass production techniques. Sullivan felt his heart hammering as he loaded the first proximity-fused shell. The 40mm projectile looked identical to conventional ammunition, but hidden inside its nose cone lay the electronic marvel that Dr. Tuve's team had perfected at Aberdeen. The shell's miniaturized radar would activate 15 seconds after firing, scanning for aircraft signatures within a 70-foot radius. Fire mission authorization confirmed, crackled the radio from Battery Command. Captain Robert Hayes had received clearance from Division Artillery to employ the new ammunition. Only battalion commanders and above knew the shell's true capabilities, a security measure that had frustrated crew-level gunners for months. The German formation split into 2 elements, with 4 aircraft targeting American supply convoys while the remainder attacked artillery positions. Oberleutnant Beyer led the second element in a diving attack that had proven effective throughout the war. Luftwaffe pilots had learned to exploit the timing delays inherent in conventional flak, using speed and unpredictable maneuvers to avoid airbursts that exploded seconds behind their aircraft. Target bearing 060. Elevation angle 20 degrees, Torres called out coordinates with mechanical precision. The Bofors crew had trained extensively with time-fused ammunition, learning to calculate lead angles and altitude corrections that required split-second timing. Today, those skills would prove unnecessary. Sullivan squeezed the firing trigger. The 40mm shell left the barrel at 2,800 feet per second, climbing toward the diving FW-190s with its electronic brain counting down the seconds until activation. 15 seconds later, the proximity fuse's radar began sweeping the sky with radio pulses invisible to human senses. The lead German aircraft triggered the fuse's detection circuit at 73 feet range. The shell exploded in a perfect sphere of shrapnel, sending steel fragments through the FW-190's engine and cockpit. Beyer's aircraft disintegrated in a ball of fire that illuminated the entire valley. "Jesus Christ," whispered Private Eddie Romano, the gun's ammunition handler. "That was a direct hit." But Sullivan realized something unprecedented had occurred. The shell had detonated in midair, creating an explosion pattern unlike anything he'd witnessed in 2 years of combat. The remaining German aircraft broke formation as proximity-fused shells erupted around them like deadly flowers. Within 30 seconds, 5 of the 8 FW-190s had been destroyed by airbursts that seemed to anticipate their evasive maneuvers. The surviving pilots fled north in terror, reporting impossible flak accuracy that defied all tactical experience. American gunners across the Ardennes front achieved similar results throughout the morning. German air support for the offensive collapsed under the weight of losses that no one could explain. Camden, New Jersey. December 1944. The RCA Victor factory hummed with activity 24 hours a day, producing electronic components under security measures that rivaled atomic research facilities. Margaret O'Brien adjusted her safety glasses as she soldered connections on vacuum tubes destined for proximity fuses, unaware that her work would soon save American lives in Belgium's frozen forests. The assembly line employed over 3,000 workers, predominantly women who had replaced men deployed overseas. Each worker specialized in a single operation, inserting resistors, welding tube filaments, or testing radio frequency stability. The compartmentalized system ensured that no individual understood the complete device being manufactured. Production quota increased again, announced Floor Supervisor Robert Chan, reviewing the morning's priority telegrams from Washington. The War Production Board demanded 150,000 fuses monthly from the Camden facility alone, part of a nationwide effort that involved 200 factories across 38 states. Margaret's station focused on ruggedizing vacuum tubes to survive artillery acceleration. The delicate electronic components had to function after experiencing forces that would crush conventional radios. RCA engineers had developed specialized mounting techniques using synthetic rubber compounds that absorbed shock while maintaining electrical connectivity. Armed guards patrolled the factory floor, monitoring workers who had undergone FBI background investigations. The Proximity Fuse program maintained security protocols established for the Manhattan Project, recognizing that German knowledge of the weapon's existence could compromise its tactical effectiveness. Workers signed agreements acknowledging that disclosure of production details constituted treason. The contrast with German manufacturing capability was stark. By late 1944, Reich armaments production had collapsed under Allied bombing and resource shortages. German factories operated at 20% capacity due to fuel rationing and raw material scarcity. Meanwhile, American industrial output reached levels that seemed impossible to enemy intelligence analysts. "Each tube we complete shortens the war," Margaret told her younger sister Dorothy, who worked the next station on the line. The sisters had lost their brother Tommy at Normandy, making their factory work feel like personal vengeance against the Nazi regime. Their individual contributions seemed insignificant, but collective American production dwarfed German capabilities by ratios approaching 10-1. Quality Control Inspector James Liu examined finished vacuum tubes under magnification equipment that revealed imperfections invisible to naked eyes. Each component underwent testing that simulated combat conditions, including temperature cycling, vibration stress, and electrical load verification. Rejection rates remained below 2%, a testament to American precision manufacturing. Shipping clerks loaded wooden crates marked radio equipment fragile onto freight trains departing for East Coast ports. The crates contained proximity fuses that would transform battlefield dynamics within weeks. German intelligence agencies had intercepted shipping manifests but failed to recognize the strategic significance of increased electronics production. The factory's true output remained classified until after victory in Europe. Margaret and her co-workers had participated in one of the war's most decisive technological achievements, manufacturing the electronic components that would give American forces insurmountable tactical advantages. Their dedication to precision and quality had created weapons that would multiply Allied effectiveness across every theater of operations. Oberleutnant Wilhelm Bayer's replacement, Hauptmann Klaus Weber, stared at the mission reports scattered across his desk at Luftwaffe Airfield A-1. 8 aircraft had departed that morning for ground support operations near Bastogne. 3 returned, with 2 so heavily damaged they would never fly again. The mission summary defied explanation. "The American flak has changed," reported Feldwebel Gustav Richter, one of the surviving pilots. "Shells explode precisely when aircraft approach. No time delay, no predictable pattern. It's as if they can see through clouds and smoke. Richter's hands trembled as he described, watching his wingman disintegrate in a perfect sphere of shrapnel. Weber consulted intelligence briefings that had arrived from Berlin overnight. Similar reports were emerging from across the Ardennes front, inexplicable anti-aircraft effectiveness that had destroyed over 60 German aircraft in 2 days. Luftwaffe operational analysis sections demanded detailed explanations for losses that exceeded all previous combat experience. The German Air Force had built its tactical doctrine around predictable Allied flak patterns. Time-fused shells exploded at predetermined altitudes, creating scattered bursts that experienced pilots could avoid through speed and evasive maneuvers. This fundamental assumption had governed mission planning since 1940, when the Luftwaffe dominated European skies. Intelligence reports American gunners are using some form of improved ammunition, Weber explained to his remaining squadron leaders. Specifications unknown, effectiveness demonstrated. We must assume all previous tactical protocols are obsolete. The admission carried devastating implications for German air operations supporting the ground. Offensive Luftwaffe pilot training had emphasized individual skill, development, and aircraft performance advantages. German aviators had consistently outfought Allied pilots through superior tactics and technological edge. But proximity-fused ammunition rendered such advantages meaningless. Even rookie American gunners could achieve hit probabilities that exceeded expert German pilots' ability to evade. Radio intercepts from German units revealed growing panic among aircrew. Experienced pilots who had survived years of combat reported impossible flak accuracy that seemed to violate physical laws. Squadron commanders requested permission to abort missions rather than face certain destruction over Allied positions. The mathematics of attrition had shifted catastrophically against Germany. Each lost aircraft represented irreplaceable aircrew and diminishing fuel reserves. American forces could absorb tactical setbacks while maintaining strategic momentum, but German losses were permanent. The Reich possessed no reserves to replace destroyed squadrons. Weber reviewed fuel allocation reports that showed synthetic production had fallen below 10% of operational requirements. Even if the proximity fuse mystery could be solved, German aircraft lacked sufficient gasoline for sustained operations. The combination of technological surprise and resource exhaustion threatened complete Luftwaffe collapse within weeks. Unmöglich, whispered Oberst Friedrich Koller during the evening briefing. Call with Luftwaffe High Command. Impossible, he repeated, studying loss figures that indicated American anti-aircraft effectiveness had multiplied by factors approaching 1,000% overnight. German air support for the Ardennes offensive had been neutralized by a weapon system that remained completely unknown to Reich intelligence services. The sky above Belgium had become a killing field where German tactical experience counted for nothing against American technological innovation. Allied supply convoys rolled through the Ardennes valleys under clear skies for the first time in weeks. Truck drivers who had spent months dodging Luftwaffe attacks now marveled at the absence of German aircraft over roads that carried 16,000 tons of ammunition, fuel, and food daily to frontline positions. Captain John Mitchell, logistics coordinator for the 12th Army Group, studied convoy manifests that showed dramatically reduced losses to air attack. German interdiction efforts had collapsed almost overnight, allowing Allied supply operations to achieve efficiency levels that approached peacetime standards. The proximity fuse's impact extended far beyond anti-aircraft operations. Fritz has given up, observed Sergeant Mike Santos, commanding a convoy security detachment. Haven't seen a German plane in 3 days. Santos had survived 2 years of combat across North Africa and Europe, experiencing constant Luftwaffe harassment of Allied supply lines. The sudden absence of air attacks seemed almost supernatural. Supreme Allied Commander Dwight D. Eisenhower reviewed intelligence summaries at SHAEF headquarters in Versailles. German Air Force losses during the Ardennes offensive exceeded all previous monthly totals, with proximity-fused ammunition accounting for disproportionate destruction. The weapon system had achieved strategic effects that surpassed optimistic pre-deployment estimates. General Omar Bradley, commanding 12th Army Group, studied tactical reports from Corps and division commanders. Infantry units reported improved morale as German air attacks ceased. Artillery batteries operated without interference from Luftwaffe fighter bombers that had previously disrupted Allied fire missions. The psychological impact of air superiority reinforced material advantages. Every mile gained owes as much to factories back home as rifles in the field. Bradley observed during his daily briefing to Eisenhower's staff. American industrial capacity had produced weapons that multiplied battlefield effectiveness beyond traditional force ratio calculations. Democratic abundance had translated into tactical supremacy that authoritarian regimes could not match. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Railroad engineers reported increased capacity along supply routes previously subjected to German air interdiction. Freight trains carried proximity fuses, conventional ammunition, and replacement equipment to forward positions without the delays imposed by air raid alerts. The cumulative effect enhanced Allied operational tempo while degrading German defensive capabilities. Intelligence analysts noted corresponding decreases in German artillery effectiveness as Luftwaffe spotting aircraft were eliminated. Air-ground coordination had been a Wehrmacht specialty since 1939, but proximity-fused ammunition disrupted combined arms operations that had dominated European battlefields for 5 years. German tactical doctrine required revision that time and resources would not permit. Port facilities at Antwerp and Cherbourg processed cargo volumes that would have been impossible under sustained air attack. Liberty ships discharged proximity fuses, replacement aircraft, and petroleum products without the protection measures required during earlier phases of the war. American logistical efficiency had achieved levels that shocked even Allied planners. The proximity fuse had created a cascading series of tactical advantages that transformed the strategic balance in Western Europe. German forces faced Allied opponents who possessed unlimited supplies, uncontested air superiority, and weapon systems that rendered traditional defensive measures obsolete. The Reich's military position had become mathematically untenable. Detroit, Michigan. The Willow Run plant that had produced B-24 Liberator bombers throughout the war was retooling for proximity fuse mass production. Plant manager Henry Ford the Sioux reviewed production, schedules that called for unprecedented manufacturing volumes, components, for electronic weapons that would define the future of warfare. The US facility represented American industrial democracy at its pinnacle. Labor unions, management, and government officials collaborated to achieve production targets that would have seemed impossible during peacetime. Workers who had built aircraft now manufactured electronic components with precision that exceeded German capabilities by measurable margins. Abundance itself is America's deadliest weapon, observed War Production Board Chairman Donald Nelson during his inspection tour of Midwest manufacturing facilities. American factories produced more electronics than the rest of the world combined by 1944, creating technological advantages that multiplied exponentially across all theaters of operation. Copper production statistics revealed the scale of American material superiority. Monthly copper output exceeded German annual production by ratios approaching 15-1. The proximity fuse program consumed copper resources that Germany had never possessed, highlighting resource advantages that made Allied victory inevitable regardless of tactical developments. Assembly line workers like Betty Washington had mastered precision techniques that German craftsmen required years to develop. American mass production methods combined individual skill with mechanized efficiency, creating products that surpassed European artisan standards while achieving volumes that defied belief. Democratic industrial systems had proven us superior to authoritarian alternatives. Quality Control Inspector Robert Kim tested electronic components that would function reliably after storage in European weather conditions for months. American packaging and preservation techniques ensured that proximity fuses maintained specifications despite exposure to moisture, temperature extremes, and transportation stress. German industry lacked comparable standardization capabilities. Statistical comparisons with German production revealed absolute American dominance across all categories. Steel output exceeded German levels by factors of 3 to 1. Aluminum production surpassed Reich capabilities by ratios approaching 10 to 1. Petroleum refining capacity dwarfed German synthetic fuel production by margins that rendered Wehrmacht mechanized operations impossible. Transportation infrastructure supported industrial output that would have overwhelmed German logistics systems. American railroads carried proximity fuses from Midwest factories to Atlantic ports with efficiency that German observers considered impossible. The Reich possessed insufficient rolling stock to move comparable cargo volumes even if production capabilities had existed, financial resources underpinned. Material advantages that shocked German intelligence analysts. American defense spending exceeded German gross national product by substantial margins, funding research and development programs that created technological breakthroughs across multiple fields simultaneously. Democratic capitalism had mobilized resources that totalitarian economies could not match. The proximity fuse represented only one example of American technological superiority that encompassed radar, communications, computing, and precision manufacturing. German scientists possessed theoretical knowledge but lacked industrial infrastructure to translate concepts into mass-produced weapons. American democracy had achieved scientific and economic integration that authoritarian systems could not replicate. Victory in Europe would result from industrial supremacy rather than martial traditions. American factories had created abundance that rendered German tactical excellence irrelevant, demonstrating that free peoples properly equipped could overcome any tyranny through superior production capabilities. American artillery crews near Bastogne loaded 105 mm howitzer shells equipped with proximity fuses for the first time on December 28, 1944. Adaptation of airborne radar technology to ground warfare represented another evolutionary leap that would transform battlefield dynamics beyond German comprehension. Sergeant William Roberts, commanding a battery of M2A1 howitzers, studied firing tables that showed devastating effectiveness against infantry and light armor. Proximity-fused shells created airburst patterns that eliminated traditional cover advantages, forcing German troops to remain underground during American artillery barrages. The psychological impact exceeded physical destruction. Fire mission coordinates 3478, range 8,000 yards, called Forward Observer Lieutenant David Park from his position overlooking German defensive positions. Park had witnessed conventional artillery effects throughout the war, but proximity-fused ammunition promised to eliminate entire enemy units with precision that approached individual targeting. The 105 mm shells climbed toward German positions with electronic brains that would detonate at optimal altitudes above enemy troops. Unlike conventional artillery that relied on direct hits or favorable terrain, proximity fuses created lethal zones that rendered foxholes and trenches ineffective. German infantry experienced firepower that seemed impossible. Battery Commander Captain Frank Wilson monitored radio reports from multiple firing positions across the front. Artillery units equipped with proximity fuses achieved casualty ratios that exceeded all previous combat experience. Single volleys eliminated German companies that would have required sustained bombardment using conventional ammunition. The mathematics of ground warfare had been revolutionized. German defensive doctrine emphasized dispersion and entrenchment techniques that provided protection against time-fused artillery. Soldiers could survive conventional barrages by remaining in prepared positions until American infantry advanced. Proximity-fused shells negated such defensive advantages, creating air bursts that penetrated all but the deepest bunkers. Intelligence reports from prisoners of war revealed growing panic among German units subjected to proximity-fused artillery. Enemy soldiers described impossible American firepower that seemed to violate physical laws. Morale collapsed as traditional defensive measures proved useless against weapons that exploded with supernatural accuracy. The tactical implications extended beyond immediate battlefield effects. German counterattack capabilities deteriorated as proximity-fused artillery eliminated assault formations before they could engage American positions. Wehrmacht offensive doctrine required concentrated infantry attacks that became impossible under omnipresent airburst fire. Medical personnel reported unprecedented German casualty patterns consistent with overhead fragmentation wounds. Field hospitals received wounded soldiers with injuries that differed from conventional artillery effects, confirming the revolutionary nature of American firepower. German medical services lacked experience treating proximity-fused casualties. Supply requirements for proximity-fused ammunition stretched German intelligence analysis capabilities. American factories were producing electronic shells in volumes that suggested unlimited industrial capacity. German observers could not comprehend manufacturing systems that treated sophisticated radar components as expendable ammunition. The psychological warfare effects reinforced material advantages. German troops facing proximity-fused artillery lost confidence in defensive positions that had protected them throughout the war. Surrender rates increased as enemy soldiers recognized that traditional tactics offered no protection against American technological superiority. The battlefield had become a mesh of invisible fire, engineered chaos that represented the marriage of American scientific innovation and industrial capacity. Supreme Headquarters, Allied Expeditionary Force Versailles, January 3, 1945. General Dwight D. Eisenhower studied intelligence reports that confirmed the complete collapse of German air support during the Ardennes offensive. Staff officers spread maps and charts across the conference table, documenting Luftwaffe losses that exceeded all previous monthly totals. The proximity fuse has achieved strategic effects beyond our most optimistic projections, reported Brigadier General Thomas Betts, Chief Intelligence Chief. German Air Force operations had been reduced to minimal reconnaissance flights that avoided Allied positions entirely. Hitler's gamble to split Allied lines had been neutralized by a weapon system the enemy never recognized. Colonel Benjamin Dixon, 12th Army Group intelligence officer, presented statistical analysis showing correlation between proximity-fused deployment and German tactical failure. Enemy ground forces had lost air support precisely when offensive operations required maximum coordination. The timing could not have been more devastating to Wehrmacht plans. Air Marshal Arthur Tedder, Eisenhower's deputy, reviewed Royal Air Force reports confirming similar German losses across all European theaters. Luftwaffe effectiveness had declined to levels approaching zero, creating air superiority conditions that would persist through the war's conclusion. The strategic implications extended far beyond the Ardennes battlefield. Fritz threw his last punch and hit only air, observed General Omar Bradley during the tactical assessment briefing. German fuel reserves had been expended on operations that achieved no strategic objectives while suffering irreplaceable losses. The Reich possessed no capability to mount similar offensives in the future. Intelligence estimates indicated German aviation fuel stocks had fallen below 10% of 1940 levels. Synthetic production facilities had been destroyed by Allied bombing, while remaining reserves were insufficient for sustained operations. The Luftwaffe had been reduced to a theoretical force that lacked practical combat capability operational. Planning for the spring offensive into Germany proceeded under assumptions of complete air superiority. Allied ground forces would advance without fear of German air interdiction, enabling logistical operations and tactical deployments that would have been impossible during earlier phases of the war. Victory in Europe had become a matter of timing rather than outcome. General George Patton, commanding 3rd Army, requested maximum allocation of proximity-fused ammunition for his planned drive toward Czechoslovakia. Patton recognized that American technological advantages could accelerate offensive operations, while minimizing casualties among his forces. The weapon system provided tactical flexibility that enhanced strategic options. British intelligence confirmed that German High Command remained unaware of proximity fuse technical specifications. Enemy interrogation reports showed continuing confusion about inexplicable anti-aircraft effectiveness. The security surrounding American electronic weapons had been maintained despite widespread battlefield employment. Eisenhower approved operational plans that assumed German military collapse within 6 months. Proximity-fused ammunition had eliminated enemy air power while degrading ground force effectiveness through superior artillery capabilities. The cumulative effects had created military conditions that made German resistance mathematically unsustainable. The Reich had attempted to divide Allied forces through tactical surprise and concentrated armor attacks. Instead, Germany had discovered that American industrial democracy could produce technological solutions that rendered traditional military advantages obsolete. Hitler's final offensive had accelerated the war's conclusion by demonstrating absolute Allied superiority. Ordnance Department, Aberdeen Proving Ground. February 1945. Colonel William Blanchard compiled statistical summaries that documented the proximity fuse's unprecedented effectiveness across all theaters of operation. The numbers revealed technological achievements that transformed modern warfare while validating American industrial supremacy. 22 million proximity fuses had been manufactured since 1942, with production continuing at rates exceeding 1 million units monthly. The industrial mobilization represented democratic coordination between government agencies, private corporations, and academic institutions on a scale that authoritarian regimes could not replicate. American abundance had created tactical advantages that multiplied exponentially. Combat. Effectiveness data showed proximity-fused anti-aircraft shells achieved hit, probabilities approaching 90% against maneuvering targets. Conventional time-fused ammunition had never exceeded 5% effectiveness under similar conditions. The technological breakthrough had multiplied Allied firepower by factors that seemed impossible to enemy observers. Luftwaffe. Loss statistics confirmed strategic implications that extended beyond immediate tactical results. German Air Force operations had been reduced to minimal levels across all European theaters, creating air superiority conditions that would persist through the war's conclusion. Over 1,200 German aircraft had been destroyed by proximity-fused ammunition during the Ardennes offensive alone. Artillery applications had proven equally devastating against ground targets. Proximity-fused shells created airburst patterns that eliminated traditional defensive advantages while reducing ammunition consumption by substantial margins. American field artillery had achieved effectiveness levels that rendered German counterattack capabilities obsolete. Cost analysis revealed economic advantages that reinforced material superiority. Each proximity fuse cost approximately $20 to manufacture, while destroying aircraft worth $50,000 plus irreplaceable aircrew. The favorable exchange ratios had accelerated German military collapse while preserving Allied resources for final offensive operations. Production statistics highlighted American industrial capacity that dwarfed German capabilities by measurable margins. A single proximity fuse factory employed more workers than entire German electronics industries. Democratic manufacturing systems had achieved coordination and efficiency that totalitarian economies could not approach despite theoretical central planning advantages. Technical specifications confirmed American technological leadership across multiple scientific disciplines. Proximity fuse development required advances in electronics, metallurgy, precision manufacturing, and quality control that represented the pinnacle of 1940s engineering achievement. German industry lacked the foundation knowledge necessary to replicate such innovations. Security assessments showed that German intelligence had never penetrated proximity fuse production or deployment protocols. The compartmentalized development program had maintained secrecy while coordinating efforts across hundreds of facilities and thousands of personnel. Democratic security measures had proven superior to authoritarian surveillance systems, international. Implications suggested proximity fuse. Technology would influence post-war military planning and industrial development. Allied nations possessed technological advantages that would persist beyond victory in Europe, creating strategic conditions that favored democratic alliances over totalitarian alternatives. The weapon system had redefined the relationship between scientific innovation and military effectiveness. The statistics narrated a simple truth. American democracy had shortened the war through industrial innovation that rendered enemy military traditions obsolete. Numbers documented victory achieved through abundance rather than martial excellence, demonstrating that free peoples properly equipped could overcome any tyranny. Smithsonian Institution, Washington, D.C., 1975. Retired Master Sergeant William Roberts examined a cutaway proximity fuse display in the National Museum of American History. The electronic components that had revolutionized artillery warfare during World War II now seemed primitive compared to contemporary military technology, yet their impact on history remained undeniable. The museum exhibit honored the secret weapon that helped win the war, featuring testimonials from veterans who had witnessed proximity fuse effectiveness during the Battle of the Bulge. Roberts remembered loading those revolutionary shells into his 105mm howitzer, unaware that he was participating in one of the war's most decisive technological breakthroughs. These fuses saved thousands of American lives, Roberts explained to his grandson during their museum visit. German planes couldn't get near our positions once we started using them. Changed the whole war. The veteran traced the fuses, electronic circuits with fingers that still remembered the weight of artillery shells loaded during that bitter winter in Belgium. Educational. Displays documented the industrial mobilization that produced 22 million proximity fuses while maintaining absolute secrecy. School children learned about the democratic coordination between government, industry, and academia that created technological supremacy over totalitarian enemies. The story represented American values translated into military effectiveness. Dr. Merle Tuvey, now in his 70s, occasionally visited the exhibit to observe public reactions to his wartime achievement. The scientist took pride in developing weapons that shortened the conflict while minimizing casualties among Allied forces. Technological innovation had proven more humane than prolonged conventional warfare. Korean War veterans recognized proximity fuse technology in the anti-aircraft weapons they had operated during 1950-1953, the same electronic principles that destroyed German aircraft over Belgium had protected American forces against communist air attacks in Asia. Continuous technological evolution maintained democratic military advantages. Throughout the Cold War, Vietnam era, artillery officers studied historical applications of airburst ammunition that informed contemporary tactics. Proximity-fused shells had evolved into sophisticated systems that provided precision firepower while reducing collateral damage. American technological leadership continued to influence global military development decades after World War II. Congressional testimony from Ordnance Department officials revealed the strategic implications of proximity-fused development. American industrial capacity had produced electronic weapons faster than enemy forces could adapt their tactics, creating technological advantages that shortened the war by months. Democratic abundance had proven superior to totalitarian efficiency. International visitors marveled at American scientific achievements that had transformed modern warfare. The proximity fuse represented democratic values expressed through technological innovation, free peoples collaborating to defeat tyranny through superior industrial organization. The exhibit demonstrated American soft power through historical example veterans organizations, sponsored educational programs that emphasized proximity fuse development as an example of civilian contribution to military victory. Factory workers, scientists, and engineers had participated in weapons development that saved countless lives while accelerating the war's conclusion. Home front mobilization had been as decisive as battlefield courage. The museum display concluded with a simple observation. In Europe's coldest winter, American innovation lit the skies with fire and turned the tide of history. The proximity fuse legacy continued to influence military technology while serving as a reminder that democratic societies possessed inherent advantages over authoritarian alternatives. If you enjoyed this story, I handpicked this next story that you will enjoy. Please don't miss this one. Click here to watch it.